Hello, my name is Damian Kilday, and in my deep learning final project, I trained a neural network to correctly identify different types of energy utility customers based on their energy usage patterns. So in this presentation, I'm going to talk through the technology I used. I'll give a brief tutorial on how to set up your environment if you want to run this same project. I'll talk through the data that I used to train the neural network in this dataset section. Briefly touch on the architecture of the neural network model that I designed, and the approach for training, as well as the results for training, validation, and testing. And then at the end of the presentation, I will give a demo of the code that I use to build and test the model. So my deep learning environment consisted of a Microsoft Surface Pro 3 laptop running an Ubuntu OS within VMware Player. And for software, I used Python, Jupyter Notebook, and TensorFlow, Keras, NumPy, Pandas, and sklearn. And I'll give a brief how-to to set up your own environment, or at least the steps that I walked through. So the first thing I did was download VMware Player. I'm using version 12, and here's the URL for that. And then after downloading VMware Player and installing it, I downloaded Ubuntu version 16.04 LTS from this URL, and I downloaded the ISO. And once you do that, and you have VMware Player installed on your machine, you can create a virtual machine within VMware Player. And the specs that I used was just one CPU for my virtual machine, 4 gigabytes of memory, and 30 gigabytes of disk. And after you have the ISO downloaded for Ubuntu and you have your virtual machine created, you can install Ubuntu on your virtual machine within VMware Player. Once you have your Ubuntu OS up and running, you can download Anaconda from anaconda.com for Linux, and then you can install Anaconda using these steps that I have here. Make sure that you set your path variable correctly and restart your machine after you've installed Anaconda. And then you need to create your Python 3.6 Conda environment for TensorFlow with this conda create command here, and then you need to activate your conda environment with source activate, and then whatever the name it is, or the name of your conda environment. I name mine TF. After that's all installed, then you can install your TensorFlow library, your Keras, Pandas, NumPy, and sklearn, and you do that all within your conda environment using pip install commands. Once you have all of that installed, you can take the Python notebook that I've provided, and it should run, and you'll be able to train the network and test the output yourself. So for a data set, I was unable to find real customer energy usage data. So I generated a simulated data set using Microsoft Excel. I created 24,000 simulated customers, each having an hourly measurement for 7 days. 12,000 of the customers were used for training and validation, and the other 12,000 were used for testing. The randomization was used to simulate real energy usage patterns for residential customers, for commercial customers, and then also for industrial customers. And I used randomization so the data wouldn't be too uniform. For the model, I created a 5-layer densely connected architecture with dropout layers after each hidden layer, the last layer being a softmax, one hot encoded layer of 3 neurons to classify the data sample into 1 of 3 customer types: residential, commercial, or industrial. To train the model, I used data samples for 12,000 customers and designated 80% to train and 20% for validation. The model was trained for 50 epochs with a batch size of 32, and I used categorical cross entropy as the loss function and stochastic gradient descent as the optimizer. with a learning rate of 0.00001. After training the model, I found that the built-in model evaluate function only showed a test accuracy of 76% and a validation accuracy of 66%. This was confusing to me, so I created another custom function to evaluate the test data and was able to confirm that the network was 100% accurate on the test data set of 12,000 customers. All right, so at this point, I will perform a demo of the actual code. So let me jump into my Ubuntu operating system. All right, so this is the Jupyter Network, or Jupyter Notebook, that contains the code for my final project for this neural network. So the first thing we got to do is import a number of libraries. So Keras, Pandas, NumPy, sklearn, and Matplotlib, which is, all right, and then we set up our functions. So I create an application variable called model name. This is the name that I'll use to actually save my model to disk, simple dense. And then I have a number of functions that I'll jump through quickly. The first function is the print sample. This is basically just if you want to print out a sample of test data or training data, you can use this function to do that. The next function is create simple dense model. This method is the model that actually creates or generates. This method generates the actual neural network model. And you can see it's a sequential model. It's got 1, 2, 3, 4 hidden dense layers, and then all followed by dropout layers, and then one last densely connected layer, which is the output layer for which has softmax activation. The next method is our compile model method, and we have categorical cross entropy as the loss function, and the optimizer is stochastic gradient descent with a learning rate of 0.00001, and we're capturing the accuracy metrics for compilation. Next method is the save model method. This allows us to save our model to disk, our trained model to disk, and then I also have a load model. So once it's saved to disk, we can load it back into memory again. I have a get label method, and get label is you pass in a prediction, a one-hot coded prediction, and it will get the actual label which was in the original file for that prediction, so residential, commercial, or industrial. Predict customer, this is used for testing the model manually, so you can pass usage data or a customer usage record into the model, and it will output a prediction for you. And then print prediction, this will, again, you can pass in a usage record and the model, and it will actually give you a human readable prediction for that usage record, energy usage record. And then the last method we have here is a plot record, which will plot the graph of validation accuracy versus test accuracy during training. Okay, so now that we've gotten through the methods, let's load up our data set. So to load the data set, we use Pandas, and our data set is a comma-separated value text file. And so Pandas is good at importing that type of data, and there's a read_CSV method we'll use to do that. So this is the training data that we're loading in initially with Pandas. Once we load it, we shuffle the data, so all the records are split up, and we don't have like all of our, for instance, all of our commercial records aren't in one big jumble of data at the beginning of the data set. So we're shuffling all the records to help achieve some randomization. After we've shuffled the records, we break our data set into X and Y, and X is the first 168 columns of the CSV, which is the actual energy usage measurements for that customer. And then the last column, the Y, is the 169th column is the actual label, which specifies what type of customer that is, whether it's residential, commercial, or industrial. And then once we've loaded the data set, we one-hot encode the labels. So I'll run that. It takes just a moment to load the data set. A few seconds. All right. So now that we've loaded the data set, we can create and train the model. So we execute our create simple dense model method, which we had up above. That will create the model and then print out the model architecture. So you can see here again, we have the 1, 2, 3, 4 hidden dense layers with dropout layers, and then the last output layer, which is the softmax layer with 3 neurons. Okay, at this point, we are ready to train our model. Before I kick this off, just want to note a couple things. We have the validation split, which means that of 0.2. So 20% of the customer records are going to go to validation, 80% are going to go to training. We have 50 epochs and with a batch size of 32. So at this point, I'm going to start training the model. And it's going to take a number of minutes for this to complete. And so what I'm going to do, I'll go ahead and pause the recording and let this finish, and then I'll rejoin you in a moment. Okay, so you can see here that we've ran 50 epochs of the model, and we have an accuracy of 76% and a validation accuracy of 66%. And we can go ahead and plot that. And you can see here our plot. So we're going to go ahead and save this model to disk. And now we're going to test the model. So just like before, we're going to go ahead and load up a model using our load model method with the same compilation settings. So let's do that. That'll take just a few seconds. So now the model is loaded from disk. And this time we're going to read in a new data set that the network has never seen before. This is the test data set, so testdata.csv. Just like before, we'll use pandas to read it in. We'll shuffle it, shuffle the data set, break it out into 168 columns of test data, and then the labels. So we'll go ahead and grab that. And now we'll evaluate the model. So interestingly, when we evaluate this model, you're going to notice that, like before, during training, it's going to run all 12,000 test samples through the network, and we come up with 66% accuracy. So this, from my perspective, I thought that that was fishy. There was something strange about that. So I created my own custom evaluate method to be able to pass in a single customer usage sample into the model, and it would tell you if that if the model predicted that customer correctly or not, returning true or false. And so I loop through all of the data in the test data set, and I come up with the total number of hits and misses. So I'm going to go ahead and start this, and it will take a few minutes to run. So I'll go ahead and I'll pause the recording, and then I'll come back when it's completed. Okay, so you can see that the evaluation completed for the test data set. We have 12,000 hits and 0 misses. And so there were a total of 12,000 records. That's the entire data set. So it looks like the model is, with the test data, is 100% accurate. So that's good news. As to why the method up above, the model.evaluate method, showed a accuracy of 66% and 77%, I do not know. But what I do know is I've confirmed it using a custom method that the model is accurate. So these are very promising results, and I believe this method of customer classification would be worth further investigation with real customer energy usage data. So thank you very much for watching my deep learning final project, and have a great day or night.